Alright folks, here's the second part of the coil, which is very important. It's the capacitor in parallel with the coil forming a typical LC circuit. You see, the capacitor, I experimented with values with my setup, and the 0.33 UF seemed to give me the best results, so I stick with it. So you see now folks, with the addition of the capacitance in the system, this no longer becomes a simple pulsing coil here. What we have to take advantage of, and I've hinted at this before but never went into details, is the golden ratio, okay? So the idea is to trigger our coil at a low frequency and essentially tap into the third harmonic, which it happens to be stronger, or better words, richer in radiant energy, and tap into that because nature can better interact when you do it this way. Because if you want to look this up with the golden ratio, it's a universal concept. So if you're looking at the environment, you want to get the best kick out of the environment, you want to stick with the golden ratio is what I'm getting at here. So with that said folks, what happens, let's say here, we want to use high frequency, okay, and I'm going to explain why. And all the best effects happen at high frequency, like in the kilohertz. Taking the golden ratio into consideration here, what we want to do is actually trigger this with high frequency, of course, let's say in the kilohertz, but the system, let's say, is going to be tuned at maybe 3 times the input frequency. So are you following me here, folks? What we're doing here is we're taking a high frequency and converting it to RF. You see, the coil itself, which will resonate at 3, the harmonic of 3 of the fundamental frequency that we're driving it with. So let's say we're driving it at 22 kilohertz. You can see why I'm getting all this radiant energy on the shortwave band that saturates my whole apartment. And maybe this is giving you a hint, folks, because now we're playing with RF, a little bit of Gerald Morin here. This now is RF. See, this coil is an RF generator now because of the LC circuit. We're pulsing it with a lower frequency and we're getting a lot of RF in the output, okay? At higher frequency, of course. All we're doing is like a swing. This little capacitor here in part is responsible for upshifting the frequency and giving us real oscillations, real RF in return, okay? So there's another part of the quote-unquote secret there. Some of you may already know, and when we're playing on RF, it's a whole different ballpark. So now we're getting RF. So we're essentially charging our system back with RF now. It's RF hitting our capacitors and batteries and dump circuits, whatever you want, okay? So I have to stress that we are, for all of the fascinating effects to really pronounce themselves, is an effect of RF, okay? All right. So I'll move on to the next quote-unquote secret with the coil here and explain. Okay, folks, before I proceed, I have to say, Tom Bearden, love him or hate him, he left us with a gift. He told us in plain English, literally, what we had to do to make these systems work. Now, probably because he used such generic terms, dumbed it down so well, that because the simplicity of it made it sound to 99.9% of the people he was a joke. For example, you're talking about electric circuits and asymmetrical regauging and how a small change can introduce a bigger change in the environment. You know, what kind of pills is this guy on, right? But the thing is, I guess people who are many people who have the dream of free energy, they figure that if you're not describing quote-unquote alien complicated technology and terminology, you must be a joke, right? But really, it was literally as simple as Tom Bearden said, right? But he gave it to us in pure English without specifically specifying the components that introduced those effects. He gave us the recipe in plain English for us to figure out. So he talks about breaking the symmetry in an electrical system, right? So how the hell do we do that? I'm thinking, breaking the symmetry, breaking the symmetry. Could it, and he talks about nonlinear systems as well a lot without actually specifying what those components are. Being in electronics, the first thing that comes to mind is nonlinear. How do we introduce nonlinear in the basic system? Well, the first thing that came to me is a diode. Well, could it be that simple? A diode is nonlinear, so my reasoning is that could be as simple as introducing a diode in the system to introduce that broken symmetry. So here we have it here, the diode is the stocky kind, which is our back EMF, which inverts the pulse and sends it back into, in my case, the little high voltage module here, which is powered by the little capacitor. More on that later. But the point here is that this diode here, in part, is very responsible for breaking the symmetry of the system here. Now, before I just go right down to the point, I need to explain it to you guys so you understand, because if I just show it to you, you won't know what's going on. So my apologies if it seems like I'm stringing you folks along. It's just to make you think and to understand here. Now, 99.9% of the people will see this, right? And what's the obvious mistake here, right? Because you've been following me for a while and I say that we are dealing with high frequency, right? So, folks, this is part of the secret right here. What seems to be the obvious issue with this diode, this specific choice of diode for this high frequency application? Come on, folks, you all know this. Some people have specified this in the comments and I never replied because I was onto something here. Yes, the diode, folks, is way too slow, right? Everyone who's played with the back EMF, the first thing they want to do is get the highest speed diode possible, because remember, I'm talking about RF, right? We want to be able to, generally speaking, the idea is that comes to mind, let's take all of that energy and use the proper diode, because this is basically made for slow speed AC 60 hertz kind of applications, right? So someone would look at this and say, this is all wrong in a schematic because I'm not taking most of the back EMF. But folks, this is the key right here. This is a asymmetrical break of the system. See, because we have a capacitor on the coil. Remember when I said the golden ratio, we're creating RF out of it? Well, we want the RF to ping pong back and forth in this coil, you see? If we would actually have a high-speed diode here to catch all of that, we wouldn't have the optimized effect. So what I'm getting at is the diode is gating the majority of the back EMF and only allowing the slow frequency to come through. It's a very sharp break of the symmetry, and the extra is free to bounce back and forth and amplify in resonance with the coil. So we're using resonance, but folks, we don't want to kill that resonance by sucking out all of the energy that triggers it, right? So here's again, I'm stressing the reason why we want to run a slow diode, because we want the coil's energy to keep enhancing, because that's what we're feeding back off of. So now that I covered that, this is something, folks, I never talked about, and this is a big key to it. And in Tom Bearden terms, this is our break of symmetry, okay? So this pulse, which is only being triggered by the low frequency, is just enough to charge this little capacitor here, which is rated at, I believe it's a trying to find 2.2 UF, I think. So this is just basically a random small capacitor, just enough to, because this high voltage module, which you can find on eBay if you just search high voltage module, only requires like half a volt to operate, and then it starts spitting out thousands of volts, right? So this is it right there, the coil setup, folks. RF, we're breaking the symmetry. The slow diode allows us to tap into the low frequency only, allowing the high frequency to freely oscillate back and forth between the capacitor. This is what keeps the energy going while the pulse is on the off time, so we have a consistent input of energy on the DC side here. This is what's going on. It allows us to keep a DC. Alright, here's the second part here. The high voltage module, which I've covered before. It's pretty basic. The capacitor in the front that gives it DC. You can buy these on eBay for a few dollars, and I found what the plus and negative was. It's very dangerous as is, because this will give you a spark, so you really gotta feed it with a dead 1.5 volt battery to find out your plus and minus on here. And I was able to determine that, and I simply send the output back into the supercapacitor bank here. Now additionally, you can this is just a ohms voltage meter. You can have that in line with the input here, which gives you an idea of what's available in this little capacitor while loading up. So basically you could see if the voltage rises or drops. It gives you a better indicator if it's actually charging or discharging the bank, but this is totally optional. You could bypass this part. And again, like some other people would say, I would go with analog meters just to be more accurate with this kind of stuff. So this is the final part here, which goes back into the capacitor bank here. And the capacitor bank, of course, through the transistor on the negative side, goes back and pulses the coil here. So I will cover the switch unit next. Alright, here's the controller, folks. I had a lot of interesting, it looks messy there, but a lot of this isn't even working anymore. So I'll show you what I'm at, which is this controller module here I found on ALI Express. I simply searched for small square wave generator modules. They had all kinds. Some of them were even more simple with no display. I wanted the little display. As it looks pretty fancy, the whole thing takes about 5 milliamps to run, so it's a nice efficient controller. Okay, so this is the controller I use, which is, and right here is a NPN NTE181 transistor here. And I've got a neon connected between the collector and the I have this set up. It's been a while. The neon goes to the, I believe it's the base. It's to protect, you know, instead of having a flyback diode, I put the neon, because if ever there's something wrong and it starts to flash, we know that the transistor is getting too much reverse voltage back into it. But in my cases, many of the times the neon won't lit, so it's just an indicator, because some people have asked for the neon. I don't have the schematic in front of me there, but that will be the next part. I will release a schematic, but it's pretty self-explanatory as I explained to you. The neon is just for protection. And I started off originally with a 1 ohm resistor. This wasn't enough, because I figured that I didn't need to really bias it, because I was just pulsing it with a very low voltage. But what happened originally when I was just running this one here, it oversaturated the transistor, and it started acting more like a resistor during the on time, and it was giving me so much problems. So by increasing the resistance here to around 22K, I was able to switch it with using the very less input that I could. Okay, so you still got to use a half decent bias resistor for your trigger here. And I used to have a voltage regulator. Let me explain to you something that's really weird with the controller. Okay, in all my experiments, I haven't been able to successfully use the same power to control the controller. Whether I used isolation that would present losses, whether I used inverters, for a while I even had a rectifier on here, folks, to try and isolate it. But no matter what I try at random, there's going to be an event. I've blown up rectifiers, I've blown up diodes, and it's really strange, because this is completely isolated, and it's just using a little bit to trigger the transistor. But when we run it in line with this whole system here, remember, this is a different kind of energy. We're dealing with RF. So RF has funny ways of making itself back into the system in ways you wouldn't expect, okay? So unfortunately, the only way I was able to fix that problem is running the controller on its own little 9-volt battery for now, so it's completely isolated. All it does is switch the capacitor's own voltage into the coil, and the module feeds it back, and that's the loop, folks. So I find the 9-volt battery is just a minor inconvenience for now, because this will run your controller for like months, because there's no power that's actually coming. Well, there is, just very little, right? Until I could figure out, probably if I were to upscale this with real 12-volt battery banks, you could probably tap off one of the bank with a little rectifier and it will run this thing fine. But for keeping things simple for experiment, it was just a lot easier to run this on its own 9-volt supply. So just to clear that out. So that's all the controller is right now. This 22K going into the transistor, switching the capacitors. That's all it is. So that pretty well completes the disclosure of the system. As complex as it is, in Tom Bearden terms, it's a very simple setup. Now stay tuned for my closing remarks, a few important points, and I hope this will set you on a good path, such as I took here, and that you may enhance it well.
Alright folks, so some closing remarks here with this generator. As I've mentioned before, this is a different kind of energy, and feel free to experiment running various inductive and resistive loads, as you've seen me doing in previous videos, such as motors and light bulbs. It could even inspire you for another stage driver in a more enhanced kind of generator project you may want to work on. But my point is, whatever, it's not as simple as just taking a meter, tuning the system for a sweet spot, and then running your load, and then it's going to work. You have to remember, everything you're going to run off the back EMF sides becomes one with the system. Inductions and resistors will modify the frequency. Therefore, you're going to have to find a quote-unquote new sweet spot in the whole spectrum, anywhere from frequency and duty cycle, to actually get your light to look like it's doing over unity, it's brighter. Same thing for your motors, for them to speed up, and the load to actually drop on the input. To notice those effects, you're going to have to look around and find the sweet spot. Nothing is going to be universal. That's the thing with this. So with that said, the self-charging capacitor in the previous video worked, but unfortunately even that has an issue, and let me explain, folks. After about 7-8 hours, the voltage on the capacitor goes up to around 1 volt. That changes the internal resistance of the capacitor, and surprise, surprise, detunes the system. So I actually have to go there and do a fine tune every few hours to keep it going. This can be tedious, and if you're not paying attention, you might be looking away for an hour and you come back and holy geez, you're back down to 0.6 volts, So, and Bedini knew this, and he talked about the issues he had with tuning when you were trying to, do in a direct loop. So I'm not saying it's impossible, and it works, and it will work for a while. So if you just want to do a demonstration somewhere real quick with capacitors, and the demonstration only lasts an hour, you're going to be good. But if you run this all day, you have to take into consideration, as is the way I showed it, at some point the system will detune itself as the voltage goes up in the capacitor. So how do we deal with that? It goes back down to the famous cap dump, and Bedini had it right, folks. You would need to introduce a cap dump on the circuit that a high voltage module would charge, and that would keep, that would tighten up our frequency range with the cap dump circuit, you see? Or the other way around. You'd have to experiment with this, but the point is, by adding the cap dump, the system will only charge the cap. It will see the impedance of the cap. it will be more or less a one-time adjustment, and your system variables will never change from that point on, because you're dumping the cap intermittently back into your load. So the load, well, not the load, but the charging device never actually sees the front that way, so it won't detune the system. So Bedini had it right. So if we're really serious and we want to upskill this, the cap dump is an absolute must. And I repeat, it's an absolute must. Now in closing, I appreciate everyone who's followed me and those that have offered even donations. But unfortunately, if those who are following me understand, I've got a minor. I've I've been born with missing chromosomes more or less, and I have an effect similar to Parkinson's, and because of that, I'm basically in Canada on the system. And I'm telling you, they make it very hard. They make it either you're fully in the workforce or you're at home and you rot and die essentially. They don't give you an in-between opportunity. For example, if I were to accept even $100 donations legally, I have to declare that, and what they do is they take it away from my food money at the end of the month. So how is your donation at the end? I know it's not your fault, but for me, any better if I have to give it back to the government, then it's $100 less of food that I actually need right now in this very tight economy. It really means something. So that's the issue with that. And the problem is, if I don't say a word and just take the donation and not declare it, people who don't like me, the trolls and whatever, will show them my YouTube channel, see that I'm accepting donations, cut me off completely, then I'm on the street, I have no housing. That would be a lot more serious, folks. So unfortunately, this takes it away. I cannot accept any donations. It's unfortunate because it would really help me along the way. I really want to build the big generators. I just don't have the means. And I was always hoping that by having this YouTube channel, I might be able to meet others who are interested, perhaps who have money, who are able to travel, who have space. Even it would be more ideal to have someone local that I could, borrow their garage or whatever, but I'm open to absolutely anything, and hopefully it's just to meet people who may have those resources without necessarily affecting my personal income that I could associate with and work with. As a hobby, I'm sure we can work this up. It's scaling it up is completely practical. It's just having the resources to do it. I don't. So at this point, unless I meet someone, basically, this is pretty well going to stay where it is. But I just wanted to share with you everything I know, and basically it's up to you to refine this. And let me know what you all think, and I thank you very much for all your support. Even if it was just the comments and the keep going, especially when you're always getting hit from the other side, that'll never work. It really meant something. So thank you very much all, and have yourselves a great day.